Okay, if you'll remember the four methods for finding delta H, we've already done this one using a calorimeter. You solve Q equals MCAT, solve for Q in joules, convert it to kilojoules, then divide it by the number of moles. The next way is to use something called Hess's Law. Hess's Law says if a reaction is carried out in a series of steps, the overall change in enthalpy will be equal to the sum of the enthalpy changes for the individual steps, which means this: enthalpies are additive. And we've kind of done this before in other units. Equilibrium, we did this, and we did this in kinetics. How can I make this reaction right here out of these three reactions? The first thing I would notice is I've got carbon on the left. I need 3 carbons on the left. Here's carbon right here in this reaction. So I would probably multiply this reaction by 3. Put a 3 here, 3 here, 3 here. If I do that, I simply take my enthalpy value and multiply it by 3. The next thing I notice is I have C3H8 on the right-hand side. Here's C3H8 on the left-hand side. So I would take this reaction and flip it. Of course, if I flip this reaction, I would have to simply change this from a negative value to a positive value. And then finally, I have 4 hydrogens right here. Here I have 2 hydrogens. So I'm going to take this reaction right here and double everything. Times 2, times 2, times 2. So I'm going to multiply my enthalpy change times 2 as well. Okay? When I do that, here's that first reaction, times 2, and I doubled my enthalpy. Here's this reaction flipped over, changed my negative sign to a positive sign, and then I multiplied reaction number 3 by 3. And then that gives me, notice all the things cancel out here, I've got 4 H2s, 3 carbons, and propane right here. Okay? And then the enthalpies are additive. This plus this plus this gives me the enthalpy for this reaction right here.